Hello and welcome back everyone. Now we are going to learn about the voltage regulator. So as you can see, I have written a definition here and we are going to see that what does it actually mean. So it's our pondering time and let's get into the pondering world that what it means to be a voltage regulator. So let's begin with our pondering conditions. Okay, so the first thing first, it is a circuit that creates and maintains fixed output voltage. Well, these three are the most important keywords or couple of keywords that we do have here. It does not matter if there are any change to the input voltage or load conditions. Well, what does it actually mean? Voltage regulation means if you are getting 20 volt and you are converting that into 220 volt, so you are increasing plus 200 volts. So you are regulating the voltage in this case. Well, let me give you an example that you are using right now or you will use very soon. Well, these are the chargers I mean with. So what the chargers are and how we think about them. Well, generally a phone charger uses 15 volts, 5 volts to 15 volts, sometimes goes up to 25 volts at max in most of the cases. But the power supply of our home is around 220 volt or even more than that. So there is a voltage regulator inside what we called as adapter, and that adapter or small voltage regulator regulates the voltage and decrease the voltage, and we get our 5 volt or 15 volt as per our requirement of the device. So this is the voltage regulation. Either you can increase the voltage or you can decrease the voltage. Well, so voltage regulator keeps the voltage from a power supply within a range of compatible, which is electrical components requirement. Well, if you want to charge your smartphone or Android or iOS, whatever phone you are using right now or device you are using right now, if you give that power supply of 220 volt plus, the device will die. So what we don't want our device to die or blast or something like that condition. So we use the voltage regulation. Well, this is the reason we don't use just two wires and connect with our device and plug it into the main socket itself. We always use a charger or adapter as intermediate, because that will going to decrease or increase the voltage as per the requirement of our device, and our device will get a safe amount and will be happy with getting charged up. Okay, so this is the old day cell phone I'm trying to make where they are the numbers and all that. I know you are familiar with that. Okay, so technically we reached to a point where we can see that there are the types of voltage regulator. Well, so what we mean with the types of voltage regulator here, let's see. TYPES. No, I'm not telling you the spelling of types, I'm writing it. Types of voltage regulator. Well, what are the types of voltage regulator? Well, they can be many, but let's see the three ones, the basic three ones. Well, there is step up voltage regulator, there is step down voltage regulator, and you can also consider the third one as inverters. So these are the kind of the voltage regulators we are going to see and explore in our topic. Okay, so let's see step up and step down concept first. To understand this concept, we need to understand something called as transformers. Well, what are transformers? Transformers are small instruments, or let's just make a very basic transformer and then we will understand that what's actually happening. Okay, so I am coiling it up, providing the circuit and coiling it up again. So again coiling it up. This time I used the less coils. Okay. Now this point I would like to call it as input, and this point I would like to call it as output. So what input output I am getting? Voltage. As we are studying the voltage thing, so surely we are going to take the voltage for now. So these are the voltage. Well, let's make knowable that what the things I have done here. So this piece is either soft iron core or sometimes the permanent magnet either. So this is magnet. In one word, you can always use a magnet. Okay. And what is this? Well, this is primary coil or primary coil. Just turn or twist the copper coil. That's it. That's all what it means. And this is the secondary coil. Well, a very special phenomena happens here. Let's understand this very carefully so that we can understand the entire story that what happens. Okay, so the current starts flowing from here. Obviously, we add some kind of power source. I'm adding it with a battery, and generally we can add with any such things as ever we require. Okay, so the current is going through this, and this is our magnet as we just discussed. So that magnetic field written as B takes the electricity through the space. Yes, the space that is around you through this directional phase and provides or charge this secondary coil, and we get the voltage here. Now the regulation is possible through the number of turns. Number of turns. Number of turns here means as much as you coil your circuit. Well, in this case, I coiled 3. I coiled up 3 times my copper. Copper. Okay, so this kind of situation is what we use, and that becomes our primary coil and secondary coil. So what we mean with that? Well, if you have 10 turns on primary side and 100 turns on secondary side, we are going to get multiply 10 times the voltage. So this condition is known as step up. Well, let me give you the example so that we can understand it more. Imagine that you have 20 volt as input. So by using this device, your voltage will going to get multiplied 10 times. So your output will going to become 20 multiplied 10, which is 200 volt. So that's how it's working. Now let's see the step down side. Well, in the step down side, very simple and similar thing happens. Just have less coiling on primary side and more coiled up on the secondary side. Let's say this is coiled up 10 times and this is coiled up 2 times. 20 times. Okay, so 20 times. So this condition is step up, as we know. So what will happen with the step down? So in the step down transformer, what we need is more coiling on this side. Means maybe let's take here 20 turns this side, and we receive 10 turns as output. So the example for the first one, is if you give the input 10 turns, as 10 volt, you are going to receive the output as, can you tell me? Multiply two times. So 20 volts. Now, in the second case, if you give the input 20 volt, you are going to receive the output how many times? Can you guess that? Well, exactly 10 volts. So it becomes half. So the second one is known as step down transformer, and the first one is known as step up transformer. There is an interesting principle working behind this called as electromagnetic induction. Let me also write that so that you can understand more well. Electromagnetic induction. Well, it is made up of three words. The first word means electro, which is our electricity. The second one is magnet, which is represented by magnetic field B. This is let's represent it by E, electric field. And the word induction means transferring from one thing to another without any physical contact. So there is no physical contact. Well, that's interesting and was discovered by a great scientist, Faraday. So, Faraday got its credit. Well, let's see how it happens. When you give electricity or current in the first coil, it will going to get returned through this one. Well, very obvious thing it is. Let's say when we are using a cell or battery or AC source, whatever you like to call it. But when the current is moving in these areas, what is actually happening? The magnetic field is carrying those electrical pulses to this side, and as the number of turns are more here, we get more voltage. Well, I'm not saying we are getting more current, I'm saying we are getting more voltage. So it means we cannot multiply the current in this case, but we can multiply the voltage in this case. Like in the first one we multiplied 2, and in the second one we halved it or decreased it. So step down transformers are used in the devices or machines that require less power, and we have the supply of more power, like our chargers that use the adapter that converts 220, 240 or 280 volts converted into very simple 15 or 5 or 25 volts as per the requirement of our simple device. Now, where the step ups were used? Well, the step up transformers are used on the poles, the electrical stations, and if you are using something heavy like a heater, it is using step up transformer to increase the voltage certain number of times and provide you the voltage to run that device. Well, that's fantastic technology that is very simple to make, even create, and it is available almost in all the circuits, all the devices that require the voltage regulation. I hope you have understood that thing. We will discuss the inverter part in the later one, but for now we are going to see that what are the advantages of using the voltage regulator. Well, there are so many advantages as we know, but the main ones are it helps us to avoid the damage, avoid high or low voltage regulation. Well, if you just imagine that the electricity that's on in your home, that's coming in your home is 220 or 240 or 280 volts, but if your phone gets even 100 or 150, it will going to be blast. So it saves us from that scenario, and it In not all the cases, but in most of the cases, it also gives us feedback. Well, as the feedback form you have filled several times on several places in school, colleges, or everywhere. Sometimes we ask for the feedback too for our work. So that is feedback. It can also give us, well, it is optional, but it can also give us the feedback. Like you can feedback on this course that this course is exciting, enjoying, or you are thinking that there is more things possible and can provide your comments to improve the entire system. That is the purpose of the voltage regulation. Well, I hope you understood the voltage regulation and the voltage regulator. Now, what we are going to discuss next is linear voltage regulator. So, we are going to discuss linear voltage regulator, and further from that, we are going to discuss SMPS. I am sure that you have heard these names. Surely, if not the first one, you surely have heard the second one, SMPS. If not, don't worry, we will learn that. So, before we start this, let me tell you something. Both have its advantages and disadvantages. So, these both the things are used everywhere as a voltage regulator in various devices. Like if you are using a PC, a desktop version, you are using SMPS. Most likely. Linear voltage regulators are used where not much efficiency is required because it is obviously less complex and more efficient, and maybe cost effective for that purpose too. Because of less complexity, people have to think less, so you have to pay less. That's simple. And the most important thing, you can generalize your entire study just to become a master of SMPS or voltage regulators. So it is very, very, very vast topic to study entirely the SMPS or voltage regulator. So what we are going to do here as digital electronics engineer, because we are studying everything, so we should know that what and hows and what ifs of everything. So in the SMPS we are going to see that what it's likely to be, its advantages, disadvantages, working, and we understand its overall idea so that we can apply it digitally. Yes, because we are studying the digital electronics and not the physical electronics, so we are able to make our version for that so that we can use it for our digital electronic purpose. Well, you can later master the SMPS and how to make it in the DIY things and learn books and can become a great master of those things too. But that's a later sad thing. For now, our mission is to become digital electronics engineer or digital electronics expert so that we can understand the digital systems very well. So this is how we are going to take ourselves. So in the next one, we are going to see the linear voltage regulator and SMPS. Till this point, if you have any doubt, you may ask in the comment section. I am happy to help you out with all that. And let's see this in the next one. So see ya, stick with me, take care, and God bless.